I'm Pat Brewster with Flying Steel. We're down here at the workbench. I'm going to show you some logo etching. It's a semi-automated process that uses an Arduino to control the pulsing of the etching machine. I'm going to jump right in and do the first knife. I'll do a little bit of explaining as we go, and after we're done with the first knife, I'll explain the hardware and the process thoroughly. Thanks. Okay, we have three knives here that we're going to etch today. They are the exact same pattern. They are north wind throwing knives. I'm going to take one, place it into the contraption, grab my stencil in its plastic frame out of this bath of water. I'm going to place it on top of the knife. The stencil has stops that force it into one position, just like the knife. I'm going to apply electrolyte here. It's basically glorified salt water. Bring the marking head down, press the switch on the Arduino control box to start the cycle. The Arduino box has two LED lights. One is yellow. We see that shining right now. It tells us that this cycle is running. The total cycle time is about 45 seconds. There's a second LED light there. It's blue, and it comes on towards the end. It's a 5-second early warning. It'll flash slowly for in the last 5 seconds of the cycle, and then when the cycle's over, the yellow light goes off, and the blue light flashes rapidly to tell me that it's done. So if you hear clicking, what we're hearing is the power supply for the etching machine going on and off. And there we go, there's our 5-second early warning, the blue light flashing. And the rapid flashing tells me that it's all done. So I raise the marking head, pull off the stencil, put it back in its bath of water, and then I spray the knife with a neutralizing solution to stop the electrolyte from rusting. And then I can go ahead and grab the second knife and get it going. Let's take a closer look at my setup, and I'll talk about the process and what I do and why I do it. First of all, in between every etch, I'm dipping my stencil into this water bath, and that's just to rinse off any electrolyte residue and try to get any other contaminants off the stencil and keep it clean. With every mark, I use a fresh piece of wick. I buy the stuff in a roll and shear to size. It sits on top of the stencil like so, and I apply my electrolyte with this little squirty bottle. Now, I have my vinyl stencil glued into this plastic frame. What that does for me is it keeps the stencil flat, and it gives me a convenient way to hold on to it, move it around, and most importantly, it acts as an electrolyte dam. So if I put a little too much electrolyte on, it's going to keep it from overflowing and marking or staining my knife. Now, the actual fixture is, it might look kind of like a mess, but it's pretty simple. I'm going to get the marking head out of the way. It's a 3-point stop. So if I have a stack of identical knives, I spend a few minutes to get these stops in position, which means the knife is lined up with the marking head, and then once they're there, I don't have to do any fiddling in between knives. So I put knife number 1 in, I mark it, I pull it out, I can put knife number 2 in, and it's right in the exact same position as knife number 1. So we've got stop number 1, stop number 2, and stop number 3. And as you see, it's pretty low tech. I loosen these clamps and move these pieces G10 around to wherever I need them to go, and that's that. Now the stencil also has its own 3-point stop, and the stencil sits right there. Stop number 1 is this piece of brown plastic on the left, stop number 2 is this piece of brown plastic on the right, and stop number 3 is the head of this bolt. Now, once or twice a month, this silicone glue is going to fail, and I'll need to remake my stencil, and when that happens, I need to readjust the stops for the stencil. But no big deal, takes a few minutes, and then I'm good to go for another few weeks. So the marking head, that's this. It's made by IMG International. Their website is img-electromark.com. This unit on top is the stock product, and this is actually, the cylindrical section is actually an electrolyte reservoir. I of course don't use it that way. I squirt the electrolyte on manually, but I thought this was be convenient to buy one with the cylindrical body in it because it'd give me a lot of mounting options. So the blue plastic piece is I got this 3D printed. And it's just basically an adapter that lets me mount the marking head to this linear carriage. This linear carriage mates with the linear rail here. It's made by Pacific Bearing, and it's just a plain sliding carriage, meaning it has no ball bearings or grease. It's basically just lined with glorified Teflon. The linear rail is mounted to this extruded aluminum piece, and that's bolted from the bottom onto this G10 base plate. So the carriage slides up and down freely. I just have this great bright green rubber band here that just so happens to be the right size, such that when I slide the carriage up, the rubber band catches it. So it's held in place. When I slide it down past the rubber band, now it's free to do its thing. So it's just gravity holding it down onto the stencil. When I was first doing this, I had it set up so the rubber band was actually holding the carriage up, and I would just press it down with my finger and hold it down in place, but I realized that it worked just as well in this kind of hands-free configuration. And I imagine you could use magnets and rig up something magnetic as well. I do this steel plate on the side. That's in case I want to use this simple laser level to mark a laser line. I don't know why. I guess I'm out of batteries, but anyway, you get the idea. It has a magnetic base, so I have a piece of steel there if I want to use a laser pointer, laser level. And that about covers the contraption itself. The fixture, I guess, would be the right word for it. Again, the idea is I have a stack of knives. They're identical. I want to be able to get a knife in, mark it, hands-free, get the knife out, and get the next knife on as quick as possible. And the idea is, well, you know, knife number 3 is being marked. I'm wiping down knife number 2, or doing any other kind of preparatory steps. So it's kind of I'm working and the machine's working at the same time is the concept. So moving on to the actual electronics part, the Arduino is the name for this little board inside here. They're pretty cheap, 20 to 25 bucks. As I mentioned, I've got 2 LED lights in there. The cord coming off of it has 4 wires inside. Two of the wires are the power supply for the Arduino board. The other 2 wires in here are the signal wires that trigger the etching power supply. Now the etching power supply is a Personalizer Plus model. It's underneath the workbench. We can't see it. It takes 120 volts and it sends its power signal out through these 2 wires. The red wire, as you see, goes to this metal clip that the knife sits on top of. The black wire, as you see, goes to the marking head. Now the Arduino outputs 5 volts, so we need something that's going to take 5 volts, a 5-volt signal, and power on the power supply with that. So I was able to buy a simple relay box on Amazon, and that's all it does. It accepts a 5-volt signal from the Arduino, and when it gets that signal, it turns on the 120-volt power supply for the etching machine. Now the Arduino itself is programmed with some very simple code on your computer, and it's about as basic as programming can get. You're simply saying turn on, turn off, turn on, turn off. I added these 2 LED lights as kind of a fancy extra feature. They're totally optional. You don't need them. All you really need to have if you want to use an Arduino to pulse a etching machine or any other electronic device is just the signal wire and the lines of code that turn that signal on and off. That's pretty much it. Now the whole concept with pulsing an etching machine is that when you're etching, you have gas buildup. So you've got little bubbles that are forming at the metal surface, and they're getting in between the metal and the wick, which is saturated with the electrolyte. And if I understand correctly, they can kind of interfere with the etching process and prevent you from having a nice even etch with an even depth. Now, as you go deeper, of course, as time goes on when you're etching, you're going deeper and deeper and deeper. You're eating the metal away, and it's sucking the metal up into that wick. That's why you see the used wicks there are black. They actually contain bits of the metal that we've removed from the knives. So as time goes on, or as you get etched deeper, the bubbles create more of a problem. So the idea here is what I've got here is I've got a total cycle time of 45 seconds, and I've got rests or power off periods that are each 1 second. But we start with a 9-second on period, and then I end with a 4-second off period, and in between it's kind of a decreasing on period. So that's something you can't really achieve with a simple frequency pulsar. You can buy an etching machine power supply that has a built-in pulsing feature, but the price tag goes way up, and I don't think you have this level of control. So you're saving a lot of money, and you're getting a lot of flexibility by doing the pulsing yourself with an Arduino. And also, in my case, I thought it was a lot of fun. I guess the last thing I forgot to mention is the switch, of course, that starts the cycle is just a simple piece of sheet metal and 2 wires going to the 2 screws on the inside of the plastic enclosure. I like this a lot because it's I'm dipping my hand in the water. Maybe I've got electrolyte on it. This whole thing is totally drip proof and kind of idiot proof. All the wires are on the inside, and it's hard to mess up. It's not going to be hurt if I drop it or whatnot.